In this video, we're going to talk about twisted pair copper cabling wire standards, specifically the TIA/EIA 568A and 568B wiring standards. So what are these? Well, these are industry standard wiring standards for how we arrange the actual pins on the RJ45 connector with our cabling. And there are two specific standards, like I said at the beginning of the video. There is the 568A and there is the 568B. Now, the 568A was the original standard, and the newer one out of the two is the 568B. And I recommend that you use the 568B because that's what a majority of people use. Now, in regards to one or the other, in all reality, if you are setting up a network, you could use either of these. It doesn't matter. But a lot of people use 568B over 568A, and that's why I recommend it. So why would we want to use one versus another? Well, the thing is if you're hiring people, if you're setting up a network, if you're cabling a building, you want to stick to one standard pinout for your design. You don't want to be jumping around from 568A to 568B because you could run into issues. So if you're cabling a cable, if you cable one end with the 568A, you cable the other end with the 568B, the pinouts are going to be different, and depending upon your network, you may run into some issues. Now, newer networking equipment does have the ability to auto-sense where there's incorrect pinouts, so it's not as big of an issue. But if you have legacy equipment, that's where you run into issues. So let's assume that you do have some legacy equipment. Then what's the benefits? Well, if you're wiring everything correctly, you're going to have lower costs because you're not going to have to go back. You're not going to have to fix things. You're going to have increased interoperability because, again, you're going to have cables that you know work with one another. And then that also leads to easier maintenance. Now, let's actually take a look at these in a bit more detail. So let me go ahead and get rid of the highlighting, and let's talk about the actual differences between the 568A and the 568B. So from our last video, you already know that a twisted pair cable is composed of 4 pairs of wires, and if we unstrand those, that's going to give us a total of 8 different wires. So with our pinout, of course, we're going to have 8 different pins, 1 for each wire. Now, in regards to each pair, there's going to be a pair where one of them is going to be solid color and the other one's going to be striped with white in the same color. So in regards to wiring these out, we need to understand the order in which they go. Now, in regards to how I have this depicted here with this diagram where we see the dashes, this would be the white striped one. So for example, with the 568A, we'll just go through it from pin 1 down to pin 8. Pin 1 is going to be white and green. Pin 2 is going to be solid green. Pin 3 is going to be orange and white. Pin 4 is going to be solid blue. Pin 5 is going to be the white and blue. Pin 6 is going to be solid orange. Pin 7 is going to be the white and brown, and pin 8 is just going to be the solid brown. Now, in regards to understanding the differences between 568A and 568B is understanding which pins are actually affected between these two different standards because only 2 pairs actually change. So let me go ahead and let me get my box tool to show you the cables that do not change, and hopefully you're already seeing them. So you're going to notice that pins 4 and 5 are the same for both of these, so they don't change. And then pins 7 and 8 don't change either. So what we're going to see here is that the only ones that switch are the orange and the green. So those 2 twisted pairs are the ones that switch. In the 568A, for pins 1 and 2, it's going to be the green and the green-white. However, for 568B, it's going to be the orange and the orange-white. And then same thing for 3 and 6, they're just reversed. So all you need to do is memorize one of the 2 of these, and I highly recommend that you memorize 568B because that's the standard that I recommend that you use and most people use. Again, this is a recommended standard. If we memorize this one and we know that pins 1 and 2 and 3 and 6 are reversed, then we'll be fine. Then we can simply say, okay, well, if I know that this is a pinout for 568B, if I just switch the orange and the green, then I now know the 568A. So that's the difference between the two. Now, what I want to do is now talk about the difference between a straight through and a crossover cable, showing you the difference, and this will help you understand why these are reversed. So let's go ahead and let's take a look at that on the next slide. All right, so let's talk about the differences and the purposes of a straight through versus a crossover cable. So in networking, there are two primary types of cables that we use, and that would be a straight through cable and a crossover cable. So what's the difference and what's the purpose? Well, the difference is the pinouts, and the purpose is the types of the device that they're being connected to. A straight through cable is used for connecting unlike devices, and a crossover cable is used for connecting like devices. So what does that mean? Well, it's pretty simple. An unlike device would be something like a computer to a switch or a switch to a router. They're distinctly different devices, so they would require a straight through cable. Conversely, a crossover cable are for like devices, the same type of device. So a router to a router or a computer to a computer. So if we created the most basic type of a network that you could create, which would be just two computers connected together, that would require a crossover cable. But there's a caveat to that rule. And the caveat is now our networking devices are so smart that they can auto sense where there are incorrect pinouts. And so if I screwed up and I actually connected two modern PCs together, like the one that I'm recording this on, if I did a straight through cable, it would work just fine. But if I went back to, let's say, 1995, if I plugged in a straight through cable, it wouldn't work. I'd have to use a crossover cable. So now let's talk about the actual differences. With a straight through cable, what you're going to notice is that the pinout is the same standard on each side. So if we're going to do a 568A type of a pinout for our entire building, then we're going to use 568A on both sides for a straight through cable. And then, well, if we're going to use 568B, then of course it would be the same pinout on each side. Now, in regards to a crossover cable, all that simply is one side has 568A, the other side has 568B. So we're switching those pairs. We're switching the green and the orange pairs with a crossover cable. Now, in regards to why the green and the orange cables are switched in a crossover cable, we'll talk about that on the next slide. But before we do, I quickly want to spend some time talking about the pin locations. So let's talk about those. So in regards to the actual pin locations, pins 1 through 8 on an actual RJ45 connector, I've depicted them down here. So this is an RJ45 connector with the metal leads facing up. And with that, pin 1 is going to be at the top and pin 8 is going to be at the bottom. And what I've done is I've set it up with this one right here side by side, because this is also a 568B down here where we have the orange white, then the orange, then the green white, and then the blue, and then blue white, and then green, and then brown white, and brown. So when you're looking at these diagrams, depict these as if the metal leads were facing up as well, and these are the RJ45 connectors, and this is the actual cable itself. So I wanted to make sure that I pointed that out before we went any further. Now let's talk about why we switch the green and the orange. So to do that, we need to jump over to the next slide to help you understand the history behind crossover and straight through cables and the older category 3 and category 5 cables versus the newer ones. So let's go ahead and let's jump over to the next slide and let's take a look at that. So with this slide, I want to pose a simple question, and that is, which twisted pairs are used? And the answer is, well, it depends. So with older cables, we would only use the green and the orange pair, but with our newer cables, our gigabit Ethernet cables, which would be Cat5e and newer cables, all 4 pairs are used. Now, to explain why we have straight through and crossover cables, we need to focus in on 10 base T and 100 base T cables. So let's talk about those first. So 10 base T is our oldest standard, and 10 base T is category 3, and it supports 10 megabit per second speeds. And then 100 base T is category 5, our second oldest standard, and that supports 100 megabit per second speeds. Now, when we used these cables years ago, they only supported the green and the orange pairs, and that would be pins 1, 2, 3, and 6. And in regards to them, one pair is used to transmit data, and one pair is used to receive data. Now, to explain this the best, we're going to focus in on these two diagrams down here. So let me get rid of my highlighting first. All right, so now that all that highlighting is gone, when we take a look at these diagrams, you're going to notice that there's TX and RX, and there's a TX positive, a TX minus, a RX positive, and an RX minus associated with the orange and the green wires within these cables. So what do they mean? Well, TX signifies that that wire is going to be transmitting data, and RS signifies that it's going to be receiving data. So you're going to notice that the positive and the negative are going to be associated with the same pair, because with a pair of wires, one of them is going to be charged positively and the other one's going to be equally charged with a negative charge. So if you see an RX minus and an RX plus, know that's associated with the same pair. So let's start off focusing in on the straight through cable. So remember, straight through cables are designed for unlocked devices. So in this example, we have a PC that is connecting to a hub, and we're calling it a hub rather than a switch because we're talking about using 10 base T and 100 base T cables. And back then, hubs were pretty prevalent. So we're just simply going to say it's a hub. Now, what you're going to notice with this straight through cable design is that when we take a look at these pairs, that if they're sending on one pin, it's going to be receiving on the exact same pin on the other side. So let me go ahead and get my arrow tool ready. So let's say that this PC wants to send some data. It's going to send it out of pin 1 and 2 with the green and the green-white cable. This is going to go straight across to pins 1 and 2 on the other end that's connected to the hub, and the hub is going to receive it on pins 1 and 2. So if it sends on 1 and 2 on one side, it's going to be received on the other side with the hub. Now let me go ahead and change the color of my arrow to a different one. I do not have an orange, so we'll just go ahead and we'll use red instead. So let's say that somebody wants to send some data to the system. Well, it's got to go to the hub. So the hub is going to send it on pins 3 and pin 6 because that's where the orange pair is. So let's go ahead and let's put a couple arrows here to signify that since these are not next to each other. What you're going to see is that since we're sending on 3 and 6, well, the PC is going to receive them on 3 and 6. Pretty simple and pretty straightforward. So if it sends on pin 1 and 2, then it's going to be received on the other one on pin 1 and 2, and vice versa. Now let's take a look at the crossover cable because that's where things get a bit different. So let me go ahead and get rid of these arrows and let's talk about that crossover cable. So remember, a crossover cable is used to connect like devices such as a PC to a PC or a router to a router. Now, I want you to understand why we use a crossover cable, and that's why I created this diagram. So let's assume that we had both of these PCs, PC1 over here and PC2 over here, and what if we hooked them both up to a straight through cable and they both tried to send data to one another? Well, to understand that, we need to understand which pins are going to be used to transmit data. So remember that we're going to use pins 1 and 2. So PC1 over here is going to use pins 1 and 2, and PC2 over here is also going to use pins 1 and 2. Well, what's going to happen if they both try to transmit data to one another? Well, let me go ahead and get my arrow tool ready to go to help you understand that. So let's assume that PC1 is going to send some data over here, and then PC2 is going to send some data over there as well. What's going to happen? Well, these arrows are on a collision course. They're going to collide. So as you can see, that's why we can't use a straight through cable. They just won't work. So when we're talking about 10 base T and 100 base T and older networking equipment, that's why we need a crossover cable. So let me get rid of the highlighting and help you understand how this works. So what we're going to be doing with a crossover cable is that we're flipping the orange and the green, where on one end it's going to be listening to receive data, and on the other end it's actually going to be sending the data. So let's take a look at this in more detail. So with PC number 1 over here, we're going to be sending with our green-white pair off of pins 1 and 2, and that's going to be going down to pins 3 and 6, where PC2 is going to be listening, where it's going to be expecting to receive that data. And then vice versa with PC2. PC2 is going to be sending off of pins 1 and 2 with the orange-white pair down to pins 3 and 6, where PC1 is going to be expecting that data, where it's going to be listening in to receive it. So what we're essentially doing is on one end, we're essentially just flipping the orange and the green pairs, whereas with the straight through cable, it's going to be the same on both ends, but all we're doing is switching it up. We're going to put the orange where the green was and vice versa on the other end. And that's all that it is with a crossover cable. We're switching it up so we're able to communicate directly from one system to another and we don't have those collisions. So that's the whole purpose of a crossover cable, and that's why we use them when we use 10 base T and 100 base T. Now let me get rid of the highlighting, and now let's talk about gigabit Ethernet and why this really isn't an issue anymore. So with modern gigabit Ethernet, which would be Cat5e or newer, which would be Cat5e, Cat6, Cat6e, Cat7, and Cat8, we're going to use all 4 pairs of wires inside our cable. So we're no longer only using the green and the orange, but now we're also using the blue and the brown. And in addition to that, each pair is going to support bidirectional data transmission, which means data can go in both directions on each individual pair within that cable. So how is that different from 10 base T and 100 base T? Well, with 10 base T and 100 base T, it did not support bidirectional data transmission. It only supported unidirectional. So one of them, which would be the green or the orange, would support transmitting, and the other one would support receiving. You couldn't transmit and receive on the same pair. So that's also a difference. And all those benefits using all 4 pairs and now supporting bidirectional support really makes crossover cables antiquated. So we really only needed those with 10 base T and 100 base T. With modern gigabit Ethernet, we can now plug in a straight through cable into any device and it should work just fine. So that's the difference, and that's why we really don't need them anymore with modern gigabit Ethernet. So that's going to conclude this video. I know it was a bit on the longer side, and I know that we covered a lot. So if you have any questions, please let me know. If not, thanks for watching, and I'll see you at the next video. Take care.